Even they conceded that that model was broken. So this year, you will discover that multinational corporate interests are here in much higher numbers than ever before. They're here as corporate venturers, looking to invest in emerging companies. Extraordinarily, they're happy to invest alongside other corporate venturers. This is something really unheard of in previous emerging technology industries such as life sciences. Perhaps there was a little bit of co-investment in the IT industries when they came through. But this is the first time that we've actually seen corporate venturers actually looking and being happy to invest alongside each other in these emerging companies.
So, as you already know Monaco, or maybe not yet, you will figure out that Monaco is a very successful and very dynamic economic place. The Principality of Monaco is ruled by the same family for already 700 years.
We have the finest collection of companies that we've ever had, and we find it actually easier to eliminate companies if you look at it from this IP point of view. But those of you who have been here before will notice that there are also some fewer delegates. We went through a process of identifying those people who've been here for the last 5 years, every year, and had never done anything to assist any of the companies in that period, and we decided not to invite them. Frankly speaking, I feel the complete opposite. I feel what you're now calling Cleantech 1.0 was really people who came in on a herd instinct, who had come out of the IT sector, needed a new... But both buyers and sellers came in. Absolutely, yeah. You know, and you can go back and answer some of your questions on what is considered environmental or not. So what you had, for me, between 2005 and 2010 was a mass herd instinct into an area which started off with renewable energy. And as I said earlier on, with probably a lack of understanding of the actual geographical market. So for me, a lot of the IP, when you invest in a company, is the knowledge of how to roll out your particular technology, your particular product, in your particular market. How the right company to get the right subsidies from the right government. In other words, you could have a third-tier company in America getting 200 million subsidy, which would actually kick your butt. Yeah. Or you could have a company in China which gets phenomenal subsidies from China. And so why did solar start becoming interesting? Actually, solar started becoming interesting not just because silicon prices in extractor fell down, but because there was so much production of solar panels at one stage that the government had put so much to subsidize that actually they were starting in 2012 to be willing to sell you these panels at 20 cents in the dollar just to keep the production mechanisms going. And then the economics really came down and became interesting. So, Cleantech 2.0, frankly speaking, is about washing out all those people who jumped on the bandwagon.
If they haven't been washed out already.
Right. Yeah. People who kept it the reality of focusing, and this is the beautiful thing about what we're working on. The beautiful thing about what we're working on is to invest in this sector, I feel, you have to have a passion for environment and social sustainability. That passion has to be in there. If you invest in IT and technology, you have to have a passion for that as well. It's about feeding that passion. It's about taking a 3 euro bus from Monaco airport to here because it takes an hour rather than a 100 euro taxi, and it takes you 15 minutes longer. It's about feeding that passion to be able to actually take technology, deliver it, and you know there are loads of problems in the world with environment to solve. And with a bit of hard work, 1 or 2 years, you can find business models and work with local governments to resolve local problems very, very, very profitably.
In this instance, because as we move into Cleantech 2.0, the one thing that is, in my opinion, being a huge interest to people is the convergence of IT with Cleantech and its demands for energy efficiencies, the rocketing amount of power that is needed for data centers, for driving this big data explosion and everything else. So you will notice today and tomorrow that we have started to include these companies in Cleantech, and they are making huge differences to energy efficiency and those sort of things. And at the same time, you're beginning to see life sciences converging. When a university in the United Kingdom sends a file to Stanford University, which is a file electronically formatted in a DNA structure, sends it to Stanford University. Stanford University takes that file, which is many gigabytes, and puts it onto physical DNA the size of my thumbnail, puts it in an envelope and FedEx it back to the UK. They then take that data with a DNA reader, bog standard DNA reader, and they read all of that data verbatim, 100% off that physical piece of DNA.
So, we've always had this, and I don't think our answer in Allo's changed in the last 9 years that we've been around. First of all, we've never used the word Cleantech, excuse me, as you know, in Allo we've always considered it environmental, socially sustainable. So what will I invest in? I will invest in anything that follows the simple 3 basic rules. We, as a human race, consume and waste far too much. So I will invest in anything that truly, not because of greenwashing, but truly reduces, allows reuse, or allows recycling. And that is my core base definition. Does it reduce consumption of whatever we're doing today by a similar level? Does it allow me, rather than just reducing the amount I consume, to actually reuse the product rather than throw it? And by reuse, I mean actually take it and replace somebody buying a new product. And 3, does it allow me to recycle it? And recycle, again, out of a very different definition. We don't consider downcycling. We don't consider incineration. We don't consider waste management. That's not recycling. Recycling is taking a product of a value and making another product of equal or higher value in virgin grade material. So that's the answer to that question, and then I'll answer the second one. But for example, last year, Mungo and Innovative Capital were very generous in allowing us to launch one of our initial companies here, a company called Perpetual, which had its first launch here. And I must say this company, thanks to a lot of support from the team, has been technology that is actually able to make high value. So this is 100% plastic bottles. So you're able to take waste plastic bottles and produce a high quality, high grade material out of 100% plastic bottles at a price that is 40% lower than the cost.
Is your suit also?
Unfortunately, this is not polyester. It could be. But having said that, we now are developing in the company the technology to take textiles back into textiles within that same company, so that we can discuss another time.
Yeah, what do we do with surplus energy when we're generating it, and how can we best capitalise on that? So, a quick thoughts across the panel, I think.
So absolutely, the largest hydrogen fueling station in Germany was opened, in Europe, sorry, was opened in February last year in Hamburg. It's an electrolyzer built by our company. It's owned and operated by a utility, Vattenfall. We're in the process of starting another station in Stuttgart owned by a utility, EnBW. So this connection between renewable infrastructure, fueling, and vehicles is already being realized with the commercial eye of utilities in Germany, so absolutely. My last comment to affirm the proposition in front of us, I think the juggernaut of Germany has not just led here, but also in solar and also in wind, and Klaus was perhaps a little bashful. When you look at the coordinated effort between the German research institutes, organizations like his from a program management point of view, a coherent thinking and strategy from the government in close collaboration with industry, it's very hard to find another place in the world where energy technology has been thoughtfully moved ahead, as I say, in wind, in solar, and now also in hydrogen. And it's created a wonderful opportunity, I think, for Germany, but they've done it with an open-handedness. We know of other nations around the world where there has been a closed mentality, a protectionist mentality, and And as a Canadian company with operations in Germany, we feel free to do business, we win projects, and we feel the opportunity to participate with their leadership, which I think is a very, very positive thing.
Microwave equipment. We don't want to go into any risk areas with that particular technology. So our technology is what you see just here, which is the nozzle, the interface between the microwave and the gas. What you can see here is plasma, a methane plasma. They have different colours depending upon what gases you're using. And if you look very, very closely, you can see at the end of this quartz tube there is a black powder, and that's where the carbon starts to condense in what we call the afterglow area. Also present in hydrogen, but that's quite transparent. Very, very exciting to kind of look at it in a philosophical concept, but it tells you that carbon nanotubes is the only material in the world that could build a structure which is 1 million times higher than its growth. You have also other applications such as drug delivery. Carbon nanotubes are the only materials that have the chemical, electrical properties and also the shape to deliver drug molecules right into the cell. Something closer than us, we also have organic electronics and flexible displays. So if you have a solar camera which it looks like this, it's 100,000 times thinner than human hairs, but it's also more conductive than copper and stronger than diamond.
I was on a plane to go and give a talk at a meeting in Washington when he was going to spill the beans, and the patent was taken out while he was in the air. We don't like having to do that.
And know-how is a tricky situation to handle because know-how often vests in people, and keeping hold of people when you sell a business is very, very difficult. And so you can lose and leak know-how from your organisation. So finding a means to protect know-how as opposed to patents is a very difficult and troubling thing to handle when you're dealing with a purely technology-based business.
Unique characteristics of the nanowires, and also this that we overcome this mismatch problem between the actual semiconductor and the substrate, making it possible for us to develop these nanowires on different kind of substrates. And this is when we come to the core to Freie Nano's IP and competence, is that we have shown and developed to grow semiconductor nanowires on graphene. I guess many of you have heard about graphene. The short description of it is that graphene is a one atomic layer of carbon atoms placed in a honeycomb crystal lattice. Graphene is a remarkable material. It is flexible due to the one atom thickness, but it's also the thinnest and strongest material that exists. For example, if you can imagine a hypothetical hammock made out of 1 square meter of graphene. Actually, this one atomic layer will be strong enough to carry 4 kilos. Regarding microelectronic, graphene offer a highest electric and thermal conductivity compared to other materials. This means that we are able to develop really high efficient components due to the heat transfer. When we better transfer the heat away, we are able to adjust the actual efficiency. This will also influence the lifetime of electronic components. Today, heat is one of the main obstacles for the lifetime of electronic components. The price of graphene is already now below the price of silicon, offering the Traditional semiconductors, they are based and grown on a thick and quite expensive soil, is so far protected through 5 priority patents, covering the different aspects of growing on semiconductors. Compound semiconductors are semiconductors that is composed of 2 or more materials from the periodic focus. So, to date, we are targeting now the optoelectronic market. The optoelectronic market itself represents $18 billion market. It's the main inventor of structures and devices. Dr. Kim now here is more responsible for the actual production and growing of our semiconductor material. But in order to develop truly flexible electronic devices, all components has to be flexible. Transparent electronics isn't just a dream. They're already making prototypes in order to integrate electronics into everything from mirrors to windows, etc. So in that case also, if you're going to develop truly transparent electronics, all components has to be there. Some room for some questions.
To all of this year's award recipients.
Trading at a market cap of about $45–50 million currently. As a public company, we usually put up this safe harbor disclaimer about forward-looking statements. Very quickly, I'm going to share with you a short video that I think does a good job of condensing what keeps happening. He wants to skip right over our video, maybe it's telling you something, but I will share this with you. Fire. Since the earliest days of mankind, it has warmed our households, heated our food, and lit our path through the darkness. Generations later, fire is pervasive in our global industrial economy. Furnaces, boilers, and kilns are used to heat buildings, generating the flame to float upward. We've all observed this when we light a candle. And if we turn the candle sideways, we notice that the flame will still burn upward. Most of us have also observed a momentum-driven flame. A propane torch uses pressurized gas to create a high-velocity stream in order to accelerate the speed of the flame. This allows us to turn the torch sideways without the flame floating immediately up, or even to point it straight down, overcoming the buoyant forces. The momentum-driven flame was one of the great innovations of the Industrial Revolution.
We are developing highly innovative, low-emission techniques with significant advantages, including enhanced flame control, better heat transfer, reduced NOx, CO, and particulate, among others. In its simplest form, ECC technology comprises a computer running proprietary software, sending a low-voltage signal to an amplifier. The amplifier converts the signal to high voltage. However, the amperage and overall power are very low, amounting to less than 1/10 of 1% of the total heat input. This high-voltage signal travels a short distance to the electrodes placed in or near the flame. By manipulating body forces directly in the flame, ClearSign's electrodynamic combustion control, or ECC technology, adds a brand new dimension to the design of next-generation burners and combustion systems. 2/3 of the world's energy today is still derived from combustion and things like furnaces, boilers, and kilns that are used to generate electrical power, heat buildings, and drive all manner of industrial processes for food processing, you name it. Virtually every piece of glass, metal, wood, and plastic that surrounds us has been thermally processed at some point. And these systems use different types of fuels, they have different types of emissions challenges, but the common thread as you get up into commercial and industrial scale systems is cost. They're expensive to build, they're expensive to operate. Fuel cost is an enormous annual cost, and emissions control to comply with environmental regulations is another layer of cost, and maintenance. And all these costs to us represent opportunities by using the improvements of our technology to deliver savings in each of these areas. If you could solve any one of these problems, it would be meaningful. We're in an environment today with regard to energy and fuel fuel that's quite interesting. You know, we hear people talk about the decline of coal and the ascendance of natural gas, but if we look at the Department of Energy's latest estimate for fuel with combustion systems, it's also a fascinating time as far as the regulatory environment. So regulatory pressures in the United States, we have new regulations under the Boiler Act and Utility Act rules that impact the emissions of carbon monoxide, particulate matter, and particulate matter, what's called PM 2.5 or ultra-fine particulate matter. In Southern California and Houston, there are new regulations for exceedingly low levels of nitrogen oxide emissions that are posing challenges to combustion system operators. And in China, we have an air quality crisis. A place where they, in the middle of January, suspended operations at 103 factories, devastating economic costs associated with air quality and air pollution. And PM 2.5 has become a household word in that country. So our approach is one, again, that we think we can deliver solutions to these problems by really introducing the first major innovation in combustion in the last 150 years. And if you remember during the video, we talked about the design methods, buoyancy and momentum. Those are the two forces that combustion engineers have manipulated since the Industrial Revolution. We're literally giving them a third variable to manipulate by the use of electrostatic body forces. And this works very simply. We mount electrodes in the flame region. We want a high voltage power source. We're going to draw a very small amount of current, microamps or milliamps of current, so the overall energy usage of our system is very negligible. Harmful emissions. For example, highly efficient means of NOx reduction, where we're able to virtually eliminate flue gas recirculation and keep oxygen at low levels. That allows us to reduce NOx while maintaining fuel efficiency at high levels, unlike currently available technology. We can shape the flame to avoid what in the refinery industry people refer to as bad flame patterns, choke process throughput. And we can distribute heat more uniformly, improve heat transfer, and effectively suppress and reduce particulate matter, PM 2.5, carbon monoxide, and nitrogen. The ability to switch fuels in what is a very expensive capital plant. That in itself is a significant advantage if we can drive up the ability to achieve a return on that invested capital. But if we can also do that, achieve gains in any one of these areas, you're going to get significant attention. The ability to combine, in particular, energy efficiency or process throughput with emissions control is literally unprecedented. Our approach has been to very aggressively stake out the patent domain in this area, and in conjunction with our partners in MDB, we have filed the circuit, and you can see that the flame front is immediately pulled down to the gas nozzle. That has tremendous implications for the design of things like low NOx burners. The principal weakness in low NOx burners today is flame instability. So now we have a whole new tool that we can provide. And when Joe Colonino first saw this effect, he looked under and he said that shouldn't be possible. Well, what did he mean? He meant that a flame shouldn't be able to burn fast enough to go against the stream of several hundred feet per second gas jet. Flames burn at walking speed, tens of feet per second. They might get to 100 feet per second when they're shutting down factories, as they did recently. In the world of combustion, if you can deliver a 1% gain in efficiency, it can translate to significant gains. So we're marching to the market, just as we have in the laboratory, scaling up as we go. And if we look at the market, we can segment it by BTUs per hour. So our coal-fired power plants are tens of millions of BTUs. And as we get into the world of packaged boilers and refinery use, those are in the 5 to 10 million BTU per hour range. And that's kind of a sweet spot in the market. The cost corresponds. These coal-fired systems cost hundreds of millions of dollars to build, tens of millions of dollars to build.
To all of this year's award recipients.
Commercialization.
Our devices control how that happens. So we took those things and brought it together with the microprocessor and intelligence world provided by ARM into a product that allows traditional unknown about power management, like temperature, which sounds relatively straightforward. But some of the inverter manufacturers today would die for understanding what the temperature is of their devices. What your temperature is at any point in time. Clearly you don't want to know that every minute of the day. But if you knew that the temperature had increased continuously over the last half an hour, you can preempt that you've got a problem with your product. You can go out there, you can proactively maintain power management. We're clearly a long way from that. That's not the proposition today, but it is the proposition of the types of conversations I'd like to be having these next 2 days with people who can help provide insight or have some equal energy in applying ourselves to this opportunity. So where are we today? Into a large capital cycle, hence my background in defence and aerospace. I'm familiar with selling to large OEMs, GE, Alstom, ABB, Siemens, those sorts of companies are our customers. And we're selling on long engineering cycles, so you get into the design stage, you then qualify. Industry bodies, we've won awards for such like Startup of the Year, Best in Class Engineering, those sorts of things. We've got patents granted and a further few files, some of which have now actually just had to go ahead to go forward into granting phase. We've got development tools, in particular are three of perhaps the leading ones in addition to industrial. But over time, data center UPS, and beyond that, automotive, are all key opportunities for us.
And this really gives him unprecedented knowledge of German and Chinese relations. Also, Tim Stratford of Covington and Burling. Tim is in the firm's Beijing office and a member of the International Trade, Corporate and Public Policy and Government Affairs faculty. He was also senior counsel for General Motors when General Motors in China had a little bit of a scrap a few years ago, if I'm not correct. The session is going to be chaired by John Butt. John is head of Conduit Ventures, who you probably all know, the renowned Power and Energy Venture Fund. And John also has expert knowledge of China.
China, I guess, is limited to the level of expertise any foreigner can have of China, and I'll qualify that. But before we kick off, I just have 3 questions. I just want to gauge from the audience, how many of you have had direct involvement, either through investments or otherwise, in mainland China?
Chinese was already $77 billion and so quite hopeful they will make their goal to 2015 over 150 billion. And by the year 2017, you will see that the Chinese automotive market will be bigger than Europe and US together. Currently, there are 31 more Chinese automotive factories in construction, which brings the Chinese passenger car production capacity up to 30 million per year.
It can be driven either with hydrogen or with gasoline.
Mungo has suggested we're going to have a provocative session because after lunch we tend to nod off. So, starting with provocation, I've broken the stand. panel of Darryl Wilson, David Hart and Klaus Bonhoff. I'll let them each introduce themselves and give you a little background as to their interest in this sector, and then we'll move to Klaus to outline what the Germans are actually doing for those who don't know. David.
Good afternoon. I'm Darryl Wilson, President and CEO of Hydrogenics. We're a Canadian-based hydrogen technology company. We have offices in Belgium and Germany, and we've been very active in the German market and benefit from much of the leadership in Germany in this area. It's good to be with you this afternoon.
Fuel somewhere around the year 2000. That was when automotive companies announced commercialization of fuel cell vehicles, which then did not materialize for various reasons. We then went through a hype on biofuels. We just went through a hype of batteries. We're now probably approaching a hype on gas, natural gas that is, possibly biogas. I think what we've learned by now is that if we look at sustainable mobility solutions, it's not the solution, but it will be a portfolio of different technologies and fuels that we're looking at. But coming back to hydrogen, around about that year 2000, one of the analyses did show that yes, ultimately, if you take efficiency, CO2 emissions, and introducing renewables into the fuel sector seriously, hydrogen is one of the best options you can choose. But we don't have hydrogen introduced as a commercial fuel. We have hydrogen around for over 100 years in the chemical industry. It's a commodity in that sector. €1 billion, half of that being publicly funded by the Ministry of Transportation and the Ministry of Economic Affairs, and the other half being funded by industry. To go into this 10-year program to do market preparation for hydrogen fuel cells, not only in transportation, but half of it being dedicated to the transportation sector, also looking at fuel cell technologies in the stationary field. Düsseldorf, Cologne area, Stuttgart. We're still hoping that Bavaria is waking up soon. We have hydrogen infrastructure in place in these metropolitan areas as part, again, of demonstration activities, not as part of commercial activities. But we're very successfully testing these technologies, and we not only look into the technology, we also look into customer acceptance, safety, regulation codes and standards, and these kind of activities. In the energy system, or transitioning of the energy system, which not only means that yes, there seems to be a public consensus at this point in time to fade out nuclear power by 2022, but which also, and more importantly, includes that we all understand that we have to increase the share of renewable energies in our power sector, that we have to do everything we can do to increase the efficiency of our energy system. And if you look at the increase of renewables in the stationary power sector, and you understand that these energies are fluctuating energies, the wind comes and goes, the sun comes and goes, storage becomes a very important topic to be looked at, and this is being discussed very intensively. And again, same as talking about sustainable mobility, if you talk about storage, there's a portfolio of solutions out there, and there's not the solution. But if you do start to look into the amounts of energy you will have to save over time, store over time, just to make sure that the energy that's being produced in windmills and photovoltaic areas is not being wasted because it cannot be taken by the grid at that point in time. If you look at those amounts, and if you consider that you need seasonal storage to cover wintertime, summertime effects, you will end up with an answer that hydrogen has to play a major role in that. So all of a sudden we're discussing hydrogen as a storage media in the context of fulfilling our goals around the Energiewende. $1 billion in order, to provide energy to the transportation sector, possibly not. But then if you really boil it down to the initial risk phase, you get to completely different figures. The first few hundred of stations, they're loss-making because they're underutilized, because you still need to de-risk the technology. So all of a sudden you're talking about, for the next 5 to 10 years, about an investment of a few hundreds of millions of euros, divided by a few large companies, maybe some government support in that. So all of a sudden you talk about a picture that is very, very doable. And making or creating money in the market, at least that's my understanding as an engineer, is not too difficult if you can show that longer term there is a viable business case behind that. Plus the opportunity you have to not only sell fuel to the transportation market, but to also serve as a storage media, really making sure that building up your capacity on renewables is doable.
Society, billions and billions. Big power is dumped in Poland in the ground because it cannot dump it in Germany. It cannot be used somewhere else. So my concern is that if the law changes, and it would be very easy to say no priority over renewables, and I see utility companies lobbying at government level doing that.
I think there are three key points to address. One is that actually the regulatory driver for transport is not particularly about utilising spilled renewables. It's about reducing CO2 emissions in the long term, which you can also do using natural gas for some considerable period of time. Natural gas to hydrogen is very cost effective, and if you have to do that, because as you say, something changes in the regulation, you can still put in an infrastructure, drive down costs, and set the scene for renewables. And I know we would, and particularly Darryl, would rather have the electrolysis solution with spilled renewables, but in a pragmatic sense, there is a second option. And there are two other things. One is that, again, this is one aspect of the market. There are companies' iteration of design work, and there are some partnerships which are very important, not least with Shanghai Automotive, GM, and others. But it is not obvious that China is going to be the place where fuel cells are manufactured in the near term. Some of the componentry may be, some membrane manufacturing facilities in China will ultimately be able to undercut facilities that are currently in other jurisdictions. But certainly in the near term, the high value parts of fuel cells are likely to be manufactured in slightly more expensive and slightly less risky jurisdictions.
To me, the reality is that the large OEMs never discontinued their development. This is why we are where we are today. Hydrogen stations by 2015 in Germany, which is still part of the R&D program that we're funding. So the German government says we need to continue to improve the technology, but at the same time, those 50 stations are located throughout Germany in a way that you can actually travel from east to west, from north to south, focusing on the metropolitan areas, but including corridor stations. And the proposal that was put forward by the European Commission just 2 or 3 weeks ago actually has the spirit of how do we make sure that throughout Europe, along the major transit ways, we have hydrogen available. So that's their political motivation to make sure that Europe as a market for this technology is available. And if we look into the fact that Toyota, Hyundai, Honda are all participating in our German program with vehicles in Germany, they do that because Germany at this point in time is one of the few places in the world where 70 megapascal public fueling stations are available. Not a lot, could be more, but hey, they are available.
You mentioned the range extender concept, which I understood was what the automotive manufacturers preferred to address the range anxiety point. Surely consumers are much more comfortable and are familiar with buying gasoline, and it could be priced at a very high level for those that demanded the comfort of having a car with a range extender.
Applications such as GSM relay towers on isolated sites. So there's a real role here for hydrogen, utility and for industrial applications away from transportation.
What do we do with surplus energy when we're generating it, and how can we best capitalise on that? So a quick thoughts across the panel, I think.
So absolutely, the largest hydrogen fueling station in Germany was opened, in Europe, sorry, was opened in February last year in Hamburg. It's an electrolyzer built by our company. It's owned and operated by a utility, Vattenfall. We're in the process of starting another station in Stuttgart owned by a utility, EnBW. So this connection between renewable infrastructure, fueling, and vehicles is already being realized with the commercial eye of utilities in Germany, so absolutely. My last comment to affirm the proposition in front of us, I think that the juggernaut of Germany has not just led here, but also in solar and also in wind, and Klaus was perhaps a little bashful. When you look at the coordinated effort between the German research institutes, organizations like his from a program management point of view, a coherent thinking and strategy from the government in close collaboration with industry, it's very hard to find another place in the world where energy technology has been thoughtfully moved ahead, as I say, in wind, in solar, and now also in hydrogen. And it's created a wonderful opportunity, I think, for Germany, but they've done it with an open-handedness. We know of other nations around the world where there has been a closed mentality, a protectionist mentality, and as a Canadian company with operations in Germany, we feel free to do business, we win projects, and we feel the opportunity to participate with their leadership, which I think is a very, very positive thing.
I wanted to say just a couple of things. One is that picking up on that last point, there are definitely applications which are outside transport, and the interesting thing which I've seen in sort of 20 years in hydrogen is that when I came into this, to some extent it was an elegant, physical, ideological, purist solution which was propounded as the hydrogen economy will save the world. And now it is much more a demand-side, pull-driven, technologically appropriate industry, finance, business than it ever used to be. And that is a fantastic sea change. And I would love to be contrary, but unfortunately I have to agree with Daryl and say that part of this is due to Germany. Germany has had this very, I think, appropriate, very structured approach to pulling this through. They have a very strong industrial base, a very strong research base. Clearly they're doing it partly to ensure that that persists. And of course there could be more money, things could happen quicker, all sorts of things. But I think they've done great things. It's right for Germany. It wouldn't necessarily be right for some other countries, but I think they've got it absolutely right for what they need to do.
Let's add to that, and wouldn't talk about that in more detail. The solution is in an optimized overall system approach, including the power sector, the transportation sector, energy solutions for industry. We have an opportunity to fill those gaps, to fill the links in between different industry sectors, different policy frameworks. I think this is what we need to work on, and this is what we've started to do with a solid R&D base, which not only included fundamental R&D, but which was looking explicitly at demonstration, large-scale demonstration, real-world demonstration, making sure we do not only develop the technology, but we look at the customer, we look at the policy framework. So this cooperation is, I think, what's really driving that's the driving spirit of the discussions that we have in Germany.
This whole sector, probably it's fair to say, was birthed in Canada, where I come from, but not so long. Some years ago, we would readily concede the leadership in the sector to Germany and the things that they have done. One of the things that German friends do very well is study things deeply from an engineering point of view, and there are several studies that have been conducted. Perhaps the one I'll refer to is called the Portfolio of Powertrains for Europe. Germany was a very active part of that, as well as other European countries. The various powertrains that are available to us for automotive vehicle design, and the automotive OEMs believe that hydrogen technology will offer that range autonomy, which has become the expectation of vehicle owners. So it's primarily driven by range, is where the edge is. From an economic point of view, the data was studied very carefully, considering infrastructure and the vehicle itself.
If you have renewable electricity and you can use it at that moment, go for it. Absolutely. There is no point in turning it into something else, losing efficiency on the way, turning it back again. So, in the simplest sense, if you can use it when you make it, yes, please do. Unfortunately, as Klaus alluded to, you can't always use the renewable electricity that you have, and therefore it's better to turn it into something which you can store. Storing electricity is terribly difficult. You actually have to store something else. You store potential energy, you store chemical energy, you store all sorts of different things. So hydrogen is one option for doing that, which gives you the opportunity for very efficient, clean burning fuel, and also for arbitrage. because, again, you can use this potentially in transport, potentially in stationary applications, potentially in chemicals.
We're talking about regulations around particulate matter, around the after-treatment for diesel. In the US, this is called Tier 4 diesel emission standards, and it is going to be doubling the cost of your typical diesel engine for a piece of something like an excavator or a skid steer. Combine that with the fact that these duty cycles are already so intermittent that the engines, as they are currently sized, are inefficient for that vehicle application. Engagements, but I wanted to give you just a sample. So one example, one of our earliest programs, we worked with one of the largest, one of the top seven OEMs in the power sports market. We helped them develop a brand new electric powertrain for 6 prototype vehicles. This was early, they were just dabbling in the market, but it was a great experience for us. 6 full prototype vehicles that were tested with over 1,000 drivers around the world, got over 10,000 miles of testing.
Mandate basically is to be something between a strategic consulting company to develop, call it generically, technology strategies with Cisco's most important customers, but also be an incubator for business ideas inside the company. So in a way, being a corporate VC arm, and then last but not least, generate thought leadership, ideas that will drive the markets, will drive the industry to adopt the network as a philosophy in how you can run your corporation, your business, your processes. In that function, our team, and actually there's some of my old team members here in the room, we have started the Smart Grid business unit in Cisco 5 years ago, the Connected Vehicle business unit 2 years ago, and the latest thing we're kicking around right now is what we have dubbed multi-tenant, multi-service platform, which is an implemented enabler for big data. And what we have tried to do here, and maybe just to set the stage, what we understand is big data, we try to define it. And first of all, it's not about size, as we all know, it's about technology. It's about the shift between what we had in the past, which was mainly structured data in the sense, it was SQL parsable, to unstructured or semi-structured data. It's the shift between having data consistent and comprehensive and clean towards parallel processing and distributed sources of data. It really kind of also influences, and Mr. Leggett talked about that, the data architecture in the company, which in the past was more or less driven by, you have a data architecture in the data set and your processes, how you basically set up the hierarchy, which was largely scale-up driven. So if you need more, you do the same thing, scale it up. In the future, what we will see is having a scale-up architecture where we say we don't do it all ourselves, we give it to partners. And that's the first part where you basically go outside of the today's silo, or businesses or corporations keep their data more or less compartmentalized, clean and tidy inside. Don't share across. On the control plane, this data is mostly used for recording, not for really kind of acting upon the data. And just to give you one anecdote, and I'll stop with anecdotes, I had a discussion with a car company recently, which now does connected vehicles, and they say every year we have 1 million more vehicles being connected. We're sitting on this huge pile of data, but we don't know what to do with it. So in retrospect, they can
across to Peter in terms of the size and scope as laid out of a landscape there by Dirk, in terms of somebody that's got a completely unique view on the megastructure.
I suppose a bit like Carbon War, I worked for Arup for the last 9 years, leading their global planning business. I'm an engineer actually, but I moved into planning. And my 900 people working all over the world on city planning, and realised that all over the world, public and private sector are still operating in silos without any integrated planning systems. And therefore, when you're trying to sell products into cities around the world, you're very much selling it into a narrow silo-based decision-making process, either in the public or private sector. And yet the biggest opportunity actually lies in cracking this integrated systems approach to macroeconomics, to local community decision-making and involving the community. So land use data, agricultural use, forestry, land use, where you've got buildings, how high they are, where you've got roads and railways can all be pulled down automatically from Sentinel or Landsat programs. And then locally, you can then crowdsource your social data and your industrial performance data into the model, and the model will be configured configured to enable that to be done. So this then operates on a regional level. With this model, I believe, we should be able to establish a large-scale regional development fund that can be drawn down in the region into green growth, clean tech investment, climate adaptation investment, and social investment bonds, which together can deliver a resilient performance.
Context of this discussion, for 8 years I was Chief Information Officer for BP across the world, and a budget around $3 billion a year of that size. So I can say, I'll tell you a few insights from practicality. I also, you can hear my voice, come from a Celtic background, and I have a degree of skepticism in the same conversation. I hear big data, I hear big society, and I've not grasped yet the big society.
Good morning, ladies and gentlemen. I work for CH2 on the Hill, and for those that don't know the company, American-based company, 30,000 employees worldwide. We turn over about, I think this year we were about $6.4 billion. We work across platforms, infrastructure, telecommunications, airports, energy, water, etc. But one of our key areas and why I'm interested in the discussion in the panel today is we have clients who build data centers, the cloud, and those types of technologies. So here and now, today, clients are asking us, what are the new technologies coming out? What should we focus on today? Customer privacy is another big challenge for us. From my perspective too, where do we go with big data? What does it look like in the future? I think for me, in the short term, and more particular to this conference, it's about platforms and apps. I think that's where the drivers are going to be. But the big thing for me is, as I look around the room, most of us have children, and really they are going to be the catalyst for change in big data. They generally think differently, they're educated differently, and they interact with society differently. Their perception on security, their perception on privacy, and their perception on standardization has a different frame of reference to us today, I believe.
Human waste, nutrients, minerals, hydroponic drip feed irrigation, etc., in agriculture. Phenomenal opportunities to bring data and technology together to dramatically increase agricultural production, not just in rural areas, but also in cities. And I personally think that is a very, very big opportunity.
People choose public transport. And there's a really interesting point in there about data and its service to its people. I'm kind of narrowing it down. It's all changed. There's opportunities in new value chains.
A challenge that can pull from us more than we knew we could do. I really think that's a relevant and appropriate quote for the world we live in today. Please consider all the opportunities you look at in this life. I hope Mike Gardner, who's our VP of Engineering, but the tool beside him, or at least one very similar to that, which is a molecular beam epitaxy machine. Used to really only be used for R&D, but these days the production versions are fantastic. They can't.
The judges have distinguished as best in class, and therefore regret that my international commitments preclude me from joining you for this 6th edition. I'm confident that we will have a successful conference, fruitful exchanges of ideas, and that we will continue the important tradition of coming to Monaco to explore and promote technologies geared to sustainable development. You have, through CleanEquity, brought clean technologies to the attention of the world, journalists, politicians, and funders. Although the work is ongoing and the need for it increasing, we must recognize that the clean tech industry is shifting. We know that the spirit of clean technology, the notion that energy supplies the construction and transportation industries, can be energy efficient. We also know that small is often beautiful when it comes to new technologies and processes. In the years to come, we will see the further development of environmental finance, the impact of big data, and the growing importance of energy efficiency and information technology. In 2008, we hope that governments around the world would take decisive action to create regulatory and fiscal environments that would encourage and support the growth of the technologies we need so desperately. This was not to be, because of severe financial and political limitations. The world financial crisis has not, however, swept away the problems facing all of us. The problems of land, sea, and air pollution, climate change, deforestation, and tremendous pressures on resources and biodiversity. We undertake the necessary measures to reach energy efficiency. Since we last met at CleanEquity, I've attended the Rio Plus 20 conference on sustainable development, where I spoke, among other topics, on the role of forest industries in building a green economy, and helped to launch the Clean Revolution campaign, an initiative to identify ways of moving to a low-carbon economy. Later in the year, I welcomed the partnership between the Foundation and the Société Monégasque de l'Électricité du Gaz to extend a voluntary Monaco carbon offsetting program. It has offset over 20,000 tons of CO2 in the 4 years it has been operating, and we hope that this partnership will extend the reach of the offsetting program across the Principality. To all of this year's award recipients, thank you.
Thank you.